A virtual private network, VPN, has become a crucial tool in safeguarding privacy and security online. By creating a secure and encrypted connection over a less secure network, such as the Internet, VPNs ensure that sensitive data is shielded from unauthorized access. This encrypted tunnel between the user's computer and the VPN server makes it exceedingly difficult for would-be attackers to intercept and decipher the data being transmitted. VPNs are not only vital for individuals wishing to protect their privacy but are also essential for corporations. They enable secure connections for remote workers, ensuring that sensitive company information remains confidential and safe from cyber threats. The mechanics of VPN encryption. At the heart of a VPN's capability to secure your data is encryption. Encryption is the process of converting information or data into a code, especially to prevent unauthorized access. When you connect to a VPN, your data is sent through an encrypted virtual tunnel between your device and the VPN server. This process involves several steps. Initiation. Your VPN client, the software installed on your device, initiates a connection to the VPN server based on the credentials you've supplied. Authentication. The server verifies your credentials. Once authenticated, a secure connection is established. Encryption. All data transmitted between your device and the server is encrypted, making it unreadable to anyone who might intercept it. This section could explore various encryption standards and protocols such as PPTP, Point-to-Point Tunneling Protocol, L2TP, IPsec, Layer 2 Tunneling Protocol over Internet Protocol Security, OpenVPN, and WireGuard. Each protocol has its strengths and weaknesses in terms of speed, security, and ease of use, making some more suitable for specific uses than others. Importance of VPNs in securing data. Public Wi-Fi networks, such as those found in coffee shops, airports, and hotels, are notoriously insecure. Users on these networks are at a high risk of cyber threats, including man-in-the-middle attacks, where an attacker intercepts communications between two parties. VPNs encrypt your internet traffic, making it incomprehensible to anyone who might capture your data on these networks. This section could detail real-life scenarios where individuals and businesses have faced significant risks due to unsecured internet access and how VPNs have mitigated these risks. VPN benefits beyond security. VPNs serve a dual purpose, enhancing security and preserving privacy. By masking your IP address and routing your internet connection through servers around the world, VPNs prevent ISPs, websites, and potential attackers from tracking your internet activity. This anonymity is particularly valuable in an age where personal data is a currency traded by corporations and governments alike. Moreover, VPNs are instrumental in bypassing geo-restrictions, allowing users to access content that may be restricted in their region due to licensing agreements or censorship. This capability is a boon for freedom of information, enabling access to a global internet without barriers. Choosing the right VPN. With the plethora of VPN services available, choosing the right one can be daunting. This section should guide readers through key considerations, including security features, encryption standards, no-logs policy, speed, reliability, server locations, user interface, and price. It's also vital to consider the reputation of the VPN provider and reviews from trusted sources. Let's delve into encryption once more. Encryption is the cornerstone of a VPN's functionality, ensuring that data transmitted over the Internet is secure and private. When a VPN connection is established, the VPN client and server negotiate a secure and encrypted connection using a process known as a handshake. This handshake involves the exchange of encryption keys, which are then used to encrypt and decrypt the data sent over the connection. Types of encryption. Symmetric encryption. In symmetric encryption, the same key is used to encrypt and decrypt data. This method is fast and efficient, making it suitable for encrypting large volumes of data transmitted over a VPN connection. Asymmetric encryption. Unlike symmetric encryption, asymmetric encryption uses two different keys, a public key and a private key. The public key is used to encrypt data, while the private key decrypts it. This method is used during the VPN handshake to securely exchange the symmetric keys that will be used for the session. Encryption protocols. PPTP, Point-to-Point Tunneling Protocol. One of the oldest VPN protocols, PPTP is fast but offers weaker security compared to newer protocols. It's relatively easy to set up but is generally considered obsolete due to its vulnerabilities. L2TP, IPsec, Layer 2 Tunneling Protocol over Internet Protocol Security, L2TP, IPsec combines the L2TP protocol with the IPsec suite of security protocols, providing stronger security than PPTP. It encapsulates data twice, offering better data protection. OpenVPN, an open-source VPN protocol known for its flexibility and security. It uses the OpenSSL library extensively and offers robust security. It's highly configurable and can bypass firewalls more effectively than some other protocols. WireGuard, the newest VPN protocol, known for its simplicity and high-speed performance. WireGuard uses state-of-the-art cryptography and aims to be faster, simpler, and more secure than its predecessors. It's designed to be easy to configure and deploy, making it a promising option for both individual and enterprise use.